Greetings and wishing you all a very good day. So for our real-time software engineering project, we have decided to work on embedded tsunami warning system, alert system, and it was prepared by our group 7. As we all know, tsunami is a natural disaster, and almost each year there seems to be an outbreak of tsunami, and because of that, many lives and properties are destroyed. To avoid the loss of human lives and to warn them beforehand, we propose a real-time tsunami warning system to minimize the casualties. As for our proposed solution, the main purpose is to predict the tsunami accurately so that all the citizens near the sea level will have enough time to save their lives if a tsunami is about to hit. And for the objectives of scope, it is to make sure the tsunami can be predicted at least 1 hour before it hits, and to make sure how long it will travel after it hit the coast, and thirdly to give enough time for citizens near the sea to evacuate if a tsunami is about to hit, and lastly to give information or notification to each citizen or town nearby if they are within the range of tsunami attack. The next one is our system software requirements. Here we can see this is our use case diagram. It will work with three different subsystems. First one is earthquake data collection. It will collect data from the sensors, three different sensors. First, it will read pressure value, read the change in capacitance, and read sea level. And the second one is earthquake data computation subsystem. It will collect all those data. And it will work with a microcontroller to calculate wavelength, detect level of tsunami, and thirdly, the notification subsystem will receive a SMS warning if there is a probable chance of tsunami, and it will also send those SMS to the nearby users in case of a tsunami attack. As for our system functional requirement, the system must be able to read the pressure sensor value using proximity sensor. It will also be able to see the changes in sea level height by using the seafloor pressure measurements, and it will also calculate the wavelength, which should not exceed 100 meters, which is a very normal wavelength for the sea waves. And the next one is the system must be able to process all the input data collected from all the sensors, and it will be able to analyze those data and predict the tsunami. And if there is a probability of tsunami, the system must be able to send the SMS warning notifications to the entire citizen that is within the tsunami range, and the public will need to be able to get the status of tsunami immediately after the system shows a higher probability of a tsunami happening. So the next part is our system architecture design. For our chosen architecture, we have selected multi-layered architectural style. It is a client-server architecture in which presentation, application processing, and data management functions are physically separated, which means that if we need to work on a particular subject, we don't have to work on the whole application, but we can rather select a particular layer and work on that. And from the diagram, we can see there are three different sensors which will be connected to the satellite, and the satellite will pass on those sensor data to sub-centralized systems, and from those sub-centralized systems it will be sent again to the satellites, and the satellite will send those data to the main centralized system, where the system will receive all those data, and it will also analyze those data in order to predict a tsunami. And after that, it will be saved into the database, and the server will notify to the nearby people through the mobile application SMS for a probable tsunami warning. The second part is our three different sensors, which will be connected to the data analysis center, which will also be connected to a satellite, and it will work through a web application. That analysis center will have algorithms to calculate and predict the tsunami warning system, and if there is a chance, then it will be expanded into two other modules so within the web application server, which are tsunami prediction scale and tsunami prediction schedule. The tsunami prediction scale will tell us how long the tsunami will affect the area, and the tsunami prediction schedule will say which time the tsunami might affect, and those data will be passed on to the next component, tsunami database, and citizen database will have all the information about citizens to inform them about the probable tsunami. This is our overall class diagram for our tsunami warning system. The sea level sensor, GPS, and pressure sensors will work with tsunami warning controller, which will have main functionalities such as detect earthquakes, pressure, sea level, and warning. If there is a probable warning generation, it will pass on to the interface tsunami warning level to view the tsunami alert, and it will get data from the citizen module of our class. The next part is our component design. The first one is earthquake data collection. As I have mentioned before, there will be three different parts: reading pressure level, reading changes in capacitance, and reading sea level. The second part will be earthquake data computation package. In this package, there will be detection of detect the level of tsunami and calculate the wavelength. And the third one is our notification package, which will be receiving SMS about the tsunami warning, and it will also send those SMS to mobile application to nearby people and users. So in our SDD, there are detailed description about all those packages and component diagrams and sequence diagrams describing each functionalities and interactions between them. So the next part of our system should be our data design. In our class requirements model data design, we can see that three parts, changes capacitance, pressure level, and sea level will be connected to a reader. Reader will then send message, and the message will be delivered to the receive message component. So here is the description of our each component. Pressure level describing all the information of pressures. Capacitance will information changing, have the information about changing capacitance. The sea level will show us the readings. The reader will collect all the information, and center message will have the information about sending and warning alert to public, and receiving message will have the information to receive a warning alert message through mobile phones. And the data dictionary part, we have generated some ideas to create our database in order to work with our project. And the next part is our user interface design. Since the system is integrated with sensors and microcontroller, the system is mainly for observing of data that is collected from sensors and processor by microcontroller. It will give the analysis result to the system, which will be displaying the people responsible for tsunami warning system. So there are three parts: logging, analysis phase, and countdown phase. The first one you can see here is the login page. It is the welcome page for the respective responsible people for tsunami analysis. They will be provided an interface to log into their own system. The second one is analysis page. This analysis page will have real-time GPS, satellite model, latitude, and all the necessary information required to analyze and predict correct tsunami warning. And the third one, the countdown page. If a probable tsunami is happening, this page will tick the tsunami schedule, the time it will hit, and it will also be able to send warning towards the respective users through this module. Alright, so that's all for the project presentation. And if we want to say about our group work regarding the STAR project, although all of us group members face difficulties at MCO, but we have responded and suited quite well with the situation. We all had our part divided before each phase, and for any kind of problems and confusion, we showed them, we discussed with our team members through our WhatsApp or Discord channel, and this was a different experience for all of us working at home, but at least we all tried our best to come up with an outcome that is suitable for the project. Thank you.